Hello, this is the luckiest maths teacher in the world. Thank you so much for watching. Today I go through using the mean and standard deviation to compare data sets. So of course remember that the mean is a measure of central tendency. We use it to try and indicate the center of a set of data, whereas a standard deviation is a measure of spread. It tells us how spread out the data is. So let's illustrate the difference between these with two quick data sets. Let's say I just have a class of 3 people and they did a couple of different maths tests. So let's say in the first test the scores were 69, 70 and 71. Let's say that in the second test the scores were 42, 70 and 98. So, what do the mean and standard deviation say about these? Well, in both of these sets of data, the mean is actually 70. So if these were 2 tests that a class of 3 students did, the mean is exactly the same in both of these tests, but it doesn't really tell the whole story. Of course, in the first test, all 3 people got very close to the average of 70. There wasn't much variation at all. In this test, the second test, there was a lot of variability. So someone did really well, got 98, someone did poorly, got 42. Someone scored a long way above the mean, someone scored a long way below the mean. So if I just report the mean, that's 70, it says that, on each test the class did the same, but it doesn't tell the whole story. I could go and calculate the standard deviation for each of these, and it would tell us more about the spread. In fact, the standard deviation is the measure of variability around the mean. It gives you an indication, did most of the scores occur close to the mean, or did they occur far away from the mean? So let's calculate the standard deviation. So remember, it's not an easy calculation. So I'll calculate the standard deviation of the first test. I firstly calculate the mean, x bar 70. So I take each score and I subtract the mean and square it. Doing that for each score, I add them all up. So if I were to add up all this, it'd just be 1 squared plus 1 squared, which is 2. So the standard deviation would just be the square root of the sum of squares divided by how many scores there are. If I put that on my calculator, I get about 0.82. Now I'm going to calculate the standard deviation for the second set of scores. So again, the average was 70, and again I take each score, I subtract the mean and square it, and I add all of these up. So this is the sum of the squares, remember? And I can put that on my calculator, I get 1,568. So the standard deviation is the square root of the sum of squares divided by how many there are. And putting that on my calculator, I get about 22.9. So that's quite a big difference. The standard deviation here was 0.82. The standard deviation in the second one was 22.9. It tells us what we already know. The standard deviation being higher in the second set of data indicates that the data was much, much more spread out. That scores were generally a lot further away from the mean than they were in the first data set. So if I am, say, reporting on your scores for a test, just telling you the mean doesn't tell you the whole story. If I tell you the mean of a test is 80, it could have been the case that everyone in the class scored 80 or close to 80. It could be the case where, a lot of people got close to 100 and a lot of people scored around the 60 mark. You just don't know without the standard deviation. So what we want to do when we're comparing 2 sets of data is not just compare the mean like we did originally for these 2 data sets. We also want to compare standard deviations because they tell us a lot about the data set. So let's say I'm going to come up with an example now where I've already calculated that, and we'll go through what it means. So let's say we have another set of two classes. So let's say class A took a test, their average for the test was 60 and the standard deviation was 2, so that's quite low. Let's say class B took the same test, their average was slightly lower, 57, but their standard deviation was higher at 18. So you might be tempted to say, okay, class A has the higher mean, therefore the students did better. But if we look at all of these numbers together, the means and the standard deviations, yes, the average of class A was higher, but the variability of class B was much higher. So what that means is, in class A, most people scored around 60, whereas in class B, there would have been a lot of high scores and a lot of low scores. Now, it's impossible for me to tell you which class did better in this one. The means are close, the standard deviations are not close. So I can't look at these numbers and just say straight up which class did better. Better is a subjective term. But all I'm saying is we can't just look at the means because they don't tell the whole story. We need to also look at the standard deviations. So what, as I said, would have happened here was that in class B, there'd probably be more people who did really well on the test, scored highly, and then more people who did poorly and scored lowly. And it'll be up to you to argue which you think is better. Again, I can't give you a definitive answer. I just want you to know the reason we're doing this, we can't just compare the two means of data sets because they don't tell the whole story. All right, hopefully I haven't confused you too much. This has been the luckiest maths teacher in the world. Have a great day.